Go.
Yay! 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 Yay math! Yay math! Yay math! Yay!
Welcome to the mathemagician's lesson. Peace to all of you, peace to you, and to you. I don't have hands. Oh, but I do. I am the mathematician, and welcome. Today, there is no lesson. Just kidding. The mathematician has a sense of humor. The lesson today is... This is the lesson today. The power of the mind will help us solve. What happens in this case? Okay, anyone raise their hands slowly and confidently if you've seen something like this before. 1, 2, 3, 4, 5, 6. Ooh, nice! Alright, so volunteer to describe what we do here.
Cry.
Yes. Yes, sir.
Okay. You put it in a square root.
Okay, put it in a root.
Put it in a root.
Alright, so we're going to create a root here. Yes?
Take the denominator of the fraction.
The denominator of the fraction.
Put it outside the root.
It becomes the power of the
Becomes
root.
the power.
Yeah.
And then whatever. Oh, you put 16 in the middle.
16 in here.
And
Right,
then-
and the 1 remains outside, so we don't need to write the 1.
Exactly.
So the denominator of the exponent becomes the power of the root, as seen here. Okay. So, what is the fourth root of 16? Meaning, what times what times what times what is 16?
2.
2. Congratulations. That is the idea behind exponents that are fractions. Let's look at the next one. Oh, it has to be actually solved with our hand. It can't be done. I tried to do it magically, but I can't. I'm just a dude in a purple suit. Okay. What we do now? Yes?
You draw the square root.
Alright, so it's normally called, you normally call it a square root? It's just a root now.
Okay.
It can be, it's a radical or a root. What is the power of the root?
3.
3, good.
And
What goes inside?
8
8. And what goes outside
to the 4th power.
to the 4th power? Nice and loud, nice and loud. Okay. This is the problem. Yes, sir.
Is it possible to turn it into take the 4/3 and add a 9 and make it over 2 and make it over 1/3?
Add a 9 to what?
Make 8 9.
No. No, it doesn't work like that. Exponents don't work like that. We can't turn this into a 9 and change it. So what we could do is turn this into 2/3, right? Turn it into 2/3, and then the 3 would multiply by 4/3. Yes.
Could you not just cancel them out?
Cancel what?
Cancel the 3 and the 4. So pretty much square root, the cube root of 3 is 2.
Yeah, we're going to
2
get...
to then
Yes, we're not done yet. We're not done. Yeah, so what is the cube root of 8?
2.
2, so we write 2. The 4 is still outside. Is this what you're asking?
Yeah, except why can't you just minus 3 from the 4 if it's just...
Minus 3 from the 4.
Take the 3 from the 4.
We are not. We're not taking 3 from the 4.
Because the 3 is in the...
Well, if we take 3 from 4, what is that? 1?
1, it would be 8.
And that's not what we're trying to get.
The answer to this is not 8, though, is it?
Nope.
What is
4
this?
to 16.
16.
Sounded
I like that you're trying to find a pattern with the numbers, right? But the pattern that's set is that the denominator becomes the power of the root. All right, that's the idea. Remember, another way to do this is 8 to the 4/3. We could write 8 as 2/3. Any questions about 8 being 2/3?
Because
The reason
2
we
times
did
2
that-
times 2.
Yeah, 2 times 2 is 8. You're asking why did I do that? Okay, the reason I did that is so that when I multiply it by 4 over 3 out here, what happens?
The 3's cancel.
The 3's cancel. When you take a power to a power, what's the rule? Tell me.
Multiply.
You multiply powers to powers. Yeah? So these two multiply. And so this would be 2 to the 4 right? So cancel 12 over 3, for example.
Oh, okay.
And that's 16. All right. So that's the idea. That's the basics, and we're going to get into more stuff now.
You can
Yes.
do it either or.
Either or is fine, but you need to know how to do both so that you know how to tackle a lot of these problems. Yes?
The middle step, can you explain what you did after
This step?
Yeah.
Okay. Where did this 3 come from?
No, the one after that. I
Below?
understand that perfectly.
This one here?
Yeah.
Okay, so you're okay with the cube root of 8? Can you explain in a loud voice what the cube root of 8 means? It's okay.
So, I have no idea.
Okay, someone help him. Yes?
What times what times what?
Correct. A number times itself 3 times equals 8. What is the number times itself 3 times that equals 8? 2. 2, right? Say it loud, it's okay. Let me address it.
2.
Okay. Does that answer your question? Cube root means what times what times what. Okay? And that's what 2 comes from. And now 2 to the 4 is 16. Alrighty then. Let's do, we can fit one more here, and then we'll stop it. 125 to the negative 2 over 3. Okay. The power of your mind can solve the negative exponents, my children.
The I.
I am the mathematician with bling. Bling, 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 bling. Oh, that song's in my head. Alright, so where does the 3 go?
On the outside of the radical.
On outside of the radical. Jinx! Okay. 3. I'm making a...
Can there be a negative power?
You know the rule for that.
No.
Oh, yeah.
There it is. The 3 one on the outside. Where does the negative 2 remain? To answer that question with my question. Outside, correct?
Yes.
Yes.
Remain.
Where does the negative 2 remain? Yeah, it's good. It's leading.
That's a good one.
Objection, leading. Okay. So good. What is the cube root of 1, 2, 5?
15.
No.
No,
5.
5. 5. Alright, so that's
Think simple.
5 to the negative 2. Any questions about the cube root of 125? 5 times 5 is 25. 25 times 5 is 125. So that's 5. What's the rule for negative exponents, sir? Yes, you were saying it.
Negative. Oh, you flip it.
Okay, so what are we writing?
Inverse 1/2. Right?
No? Try again. What happens to 5 to the negative 2? It becomes what?
5 to
1/5.
the whole word. 5 to the...
Not 1/5, yes?
1 over 25.
1 over 25. How did you get 1 over 25?
Because you square it, then you put it under in a fraction.
Okay, so we're going to put it in the denominator of the fraction. Going down. Boop.
Ding!
We're there. Okay, this is 1 over 5 to the positive 2. Recall this?
Oh, yeah.
Oh, yeah!
Oh, yeah.
What? Okay. Okay. 1 over 5 to the positive 2 is 1 over 25. Questions? Concerns? Dilemmas? Comments? All right, so the mathematician. Yeah, question. The mathematician does not erase. He has better things to do and worlds to save. So allow me to erase magically. Oh, that was amazing! Wow! I'm a mathematician.
Use your powers for good, mathematician.
I will. Okay, next. Here we go. Okay. So, is there an 8th root of 81?
Nope.
No. There's not. Any questions about that? 8th root of 81, does it exist? No. No.
Imaginary?
So no, it can't be simplified yet. However, let's do what we talked about backwards. Where does this 8 go now?
Exponent.
To the exponent.
Denominator.
And what is the exponent going to be?
1/8.
Louder!
1/8.
1/8. So this becomes 81 to the 1/8. Questions about this?
Nope.
All right. Now, this was half the problem. I just decided to give it staggered. I like that word. We're going to stagger the problem. Makes me think of this. Doesn't it make you think of that?
Not in particular, but it will now.
Dude! Stagger. Okay, so this was the original problem. Alrighty? So, I'm saying, this is a new, imagine this was the problem. I just gave you the numerator first.
Over.
I gave you the numerator first, yeah. So, where does this 6 go? Someone else.
The denominator of the exponent.
Denominator of the exponent, so it would be 3 to the, everyone?
1/6.
1/6. Okay. Over. Alright, so far so good. Now, remember, thank you, that was wonderful. It's very operatic, you know. Anyway, it would be nice whenever we're dividing exponents, multiplying exponents, to create the same base, as in 81 and 3. Alright? We want to create the same base. What do you think the same base should be?
9.
This can't be made into base 9.
3.
3 is a good base. So this one's taken care of. How do we turn 81 as a base of 3? We heard it over here. Anyone else want to second it? 3 to the what is 81?
4.
4. Questions? We're creating the same base. So, let's write it in blue. Okay. 3 to the 4 is 81. This is 1 over 8 remaining outside. Over 3 to the 1/6. Radical. Okay. Very bad. Bad baby. Okay. Next. What happens when you have powers to powers? You multiply. So what do we have here? 3 to the?
1. Oh, so then it's 3 to the...
Louder.
3 to the 1/2.
3 to the 1/2. 3 to the 1/2?
3 to the
1/2.
Why? I see a look of confusion. That's why I have the job. Let me alleviate your look of confusion, my daughter, my child. So, here we have powers to powers. What's the rule for powers to powers?
Multiply.
Multiply. So what is 4 times 1 over 8?
4 eighths.
4 times 1 over 8. Remember to cancel, right? 1, 2. This is 1/2. 4 over 8 is 1/2. Are you okay?
Yeah.
Okay? Okay. 3 to the 1/2. Good. Over 3 to the 1/6. Okay. When you divide exponents of same base, what do we do with the powers?
Minus.
Minus. Very good. Minus.
Wait, can you say that again?
Okay. When we divide exponents having the same base, we subtract the exponents. Okay? Nice. Love the cinematic effect. Okay. So we subtract the exponents, that's all. This answer, 3 to the 1/2 minus 1/6.
How does that happen?
How do you subtract?
Magic.
Magic, yeah. Besides magic, how do you
Common
subtract?
denominators.
Common denominators is the way to subtract fractions.
So 3/6.
Alright, sounds good to me. 3 to the 3/6 minus 1/6. Love it. Next.
1/3.
What is 3 minus 1?
2.
6.
1/3.
Oops.
That's
Right,
it.
yeah.
Oh, the mathemagician! Oh, my magical power! Okay, it's gone. Alright, good. Nice. 3 to the 2/6, which is 1/3.
Woohoo!
Nice.
Why not?
And this is the cube root of 3.
Correct.
The cube root of 3. What?
What happens to the denominator?
Oh. Just kidding. Good job,
Just like that.
Just like that.
Just like that.
Okay, questions? Stand over
What
here.
is, wait, what's the actual problem?
This.
8 square root 81.
How do you say this? The
8.
Floating?
the eighth root, someone else.
The 8th root
The eighth root of
81
divided by
divided by the 6th root
6th
of
root
3.
of 3.
Equals.
Alright? So the eighth root of 81 divided by the 6th root of sixth root of 3. Simplify, simplify, simplify till all this stuff. And then we get 3 6 minus 1 6. 3 to the 1/3, the cube root of 3 is the answer. Alright, any questions on this? Alright, so let me get my magical powers to erase again. Alright, time to erase.
Oh.
The mathemagician is omnipotent in all places. Correct?
Correct.
Correct.
Yes,
You're like,
mathematician.
you're like, huh.
We love you.
You get an A. Fourth root of 9 is z squared. Two more. This one and another.
The mathematician, Z is a letter, not a number.
Correct. So what do we do with the 4? Remember what we do with the 4?
Is that
Denominator?
Outside the parentheses becomes the power of what?
1/4.
1/4. So what is taken to the power of 1/4?
9Z squared.
9z squared. Excellent. So 9z squared to the 1/4. Alrighty, good. How do you suggest we do this?
Square root it?
Well, no, not square root. It was a 4th root.
You multiply powers.
You want to multiply some powers?
Yeah.
So what do we do with the 9?
Let's just
No,
keep
you don't do
it.
the 9 first.
Does the 1/4 apply to the 9?
No.
Maybe like
If you multiply powers.
Yes, it does. It does.
Yeah,
It applies to the whole problem, so it does apply to 9.
Why?
Because the 2 only applies to the Z. Because you see the parentheses?
Right.
So it's
So every term here is taken to the 1/4.
Yeah.
So it's 9 to the
1/4.
1/4. And z to the
half.
half. Okay. 9 to the 1/4. It's not enough. What can we do?
Now we.
Yeah, what can we do to 9 perhaps? To change it, to simplify this more.
Oh, give it a base.
The base, were you going to say that? Yeah?
Yeah.
Yeah, what would the base be?
3
3. So 9 is 3 to the...
squared.
Yeah, 3
squared.
Right. Let's take this over here. 3 squared is 9 to the 1/4. Z to the 1/2. Alright. 3 to the... what now?
Half.
3 to the half. Any questions? Okay, now, hopefully you guys will start to realize when you take something to the 1/2, what is it like saying?
You put
Square
it
root of 3.
Square root of 3. Excellent. Square root of 3. Square root of 3. If this, okay, this becomes the denominator of the root. I'm glad you're saying that. This becomes the denominator of the root. So wouldn't you agree? That's the case for 3, right? And z as well.
So you can write Z next to it?
Yes. When you're multiplying these roots, radicals, everything can multiply in and multiply out. So remember what we talked about. Square root, it's like this is gone. This is the answer. The square root of 3z. This is the problem, this is the answer. Alrighty? Okay, good. So we have one more. One more. Yeah, so we'll leave it up, leave it up. Okay. So, I need to do some magic wand again. So, ready for magic wand. Ready? Erase! Oh, okay, cool. It's done. Ready? Oh, wow, amazing. The mathemagician has all kinds of powers. You like my hat? Na, 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 na.
Yeah.
I see looks on faces. One day you will be a mathematician too. Relax.
I know, actually.
I like that song. Okay, what do we do? Suggestions, just like we did last time.
denominator, the 8.
Yeah. Okay, can you write at the same time I do?
Yes.
Let's do it. Okay, so this equals 25. X to the 4. Y to the 8. So 1 over 8. Okay. Now, 25.
It applies to the whole.
Applies to the whole thing. Right. So what do you say? 25 becomes the product of what and what? 5 squared. So this is 5 squared. X to the 4, y to the 8, to the 1 over 8. Okay? So now the 1/8 applies to all three of those. So here we go. What is 2 times 1 over 8? 1/4. 5
5 1/4.
to the 1/4.
Wait, I.
Please, question.
How do you get from 25x to the 4th to 5 squared if it's to the.
25 is 5 squared.
Does it matter if
Does it matter what the exponent is on the outside?
No, we didn't change the
You just wanted
exponent.
to change the base?
Yeah, I changed the base first.
do you have to change the base first, or could you
No.
distribute?
You could distribute first.
Okay.
You distribute first.
Okay.
I decided to get them all ready, prep them up. So 5 to the 1/4, x to the 1/2,
And y.
and y.
Power.
Y. Questions?
That's the answer.
Almost. Okay, this is the 4th root of 5. This is the square root of x. And this is y. So, that works.
Is that the answer?
That's the answer. Yeah. Look of confusion.
That's it?
That's it.
Wait,
Nothing else we can
do you
do.
want us to put the
You can,
square,
many.
Wow.
square root x and the other square root in parentheses? Because it looks like.
Oh yeah, we can put in parentheses. Sure. Put that in parentheses. That works. It's fine. That's good. You can organize it better. Any other questions? All right. Thank you for enjoying the lesson of the mathematician. I thank you. Walk a line that's straight and narrow, spiritually sound and safe and secure and happy. Goodbye.